2.2. 2.2 is more on functions and their graphs. So we say a function is increasing on the interval f of x1, which is less than f of x2, whenever x1 is less than x2 for all x1 and x2 on the interval. A function is decreasing on the interval if f of x1 is greater than f of x2 whenever x1 is less than x2 for all x1 and x2 on the interval. What the heck does that mean? It's a whole lot of writing, right? It's a bunch of inequalities. What does that mean? So f of x is my y value, right? So these are my y values. These are my x values. Let me draw some sort of a picture. So here I have x1. Here I have x2. This will be my f. This is f of x1. This is f of x2. Okay, so which is this true about? Here I have x1 is less than x2. That's true for both. Is f of x1 less than f of x2 here? F of x1 is smaller than f of x2, right? So I have the first situation, right? My first y value, or my first x value corresponds to a smaller y value. My second x value corresponds to a larger y value. So this is increasing. So can we say that without all of these inequalities and ugliness? Can somebody try to say that to me in plain English? When the graph's going up, right? Perfect. So a function is increasing if I'm reading from left to right, it's going up, right? Blah, 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 blah. Left to right, it's going up. That's increasing, right? So this means left to right, going up. That's increasing. Good, Nolan. So for decreasing, it means if I'm reading left to right, I'm going down, right? So left to right, I'm going down. Right? We're going to read a graph like we would read a book. Increasing means left to right, I'm going up. Decreasing means left to right, I'm going down. Okay? Putting all this in easy to remember stuff. Okay, so let's think about number one. Determine the intervals for which the following are increasing, decreasing, or neither. So if it's neither, it's just flat, right? If it's not increasing, it's not going up, it's not going down. So just flat. So where do you guys see left to right, it's going down? Where is it decreasing? Decreasing is left to right, it's going down. Good. I'm going to put little arrows and we can say negative infinity. Right? The arrows at the end means it continues like that forever. What do you guys think about the brackets for that? It's going to be a parenthesis. It's going to be a soft bracket because, what did you say? For decreasing? To zero, thank you. So at 0, on the right it's increasing, on the left it's decreasing. So at 0 I can't say that it's still decreasing at 0.
Would 0 be a hard bracket then, since it's like an exact number where it becomes increasing then?
It would be a soft bracket. Because to the right of 0, it's increasing. So if you do go back and look at the inequality, it wouldn't work for like 0.1. So where is it increasing? Left to right, it's going up. 0 to infinity. So I think this is a key example in math where you have a bunch of notation that means a bunch of stuff, but if you can break it down into simple English that's easy to remember, you don't need to go through and make a flashcard with all of this stuff, right? Break it down for yourself in easy to remember English so that it doesn't seem so complicated, right? That's a key for a lot of math. All right, number 2. Why don't you guys try it? Remember, decreasing is left to right, it's going down. Increasing is left to right, it's going up. So I'm going to write down my answer. You guys write down your answer. Also, for these intervals of increasing, decreasing, we're talking about our x values, right? So I'll write down my answer. You guys write down your answer. Did I get it right? So again, I'm looking at my domain, right? I'm looking at my x values for this. So left to right, I'm going down from negative infinity to 0, and then from 2 to infinity, I'm going down 2, right? Between 0 and 2, left to right, it's going up. That's it. So that's increasing and decreasing. Are we good with that? Again, the intervals I'm talking about are my domain, my x values. Okay, so B we'll talk about, or the second part, we'll talk about relative minimum and relative maxima. So a function f of a is a relative maxima if there exists an open interval containing a such that f of a is greater than f of x for all x not equal to a on the open interval. Note that there is a maximum at x equal a and a relative maximum, and the relative maximum is f equals a, or is f of x. Let me do it again. So note that there is a relative maximum at x equals a, and the relative maximum is f of a. So what does all of this mean? You have a maximum somewhere if on the graph it's bigger, higher than everywhere else, right? Here's some more inequalities, here's some more stuff, but it's the largest value you can attain on the graph, right? That a, so there's a relative maximum at f of a if f of a is bigger than all your other y values, right? These are some y values. Relative minimum is the smallest value, right? So this right here is important. So there's a relative maximum at x equals a, and the maximum is f of a. Here there's a relative minimum at x equals b, and the minimum is f of b. So the minimum value is the y value, and you get a minimum value at your x value. Okay? So number 3 says determine the relative minimum and relative maximum for each of the following. What do you guys think for number 3? Do you have a minimum? Do you have a maximum? Lester. So Ben's saying a maximum would be infinity and the minimum would be 0. So the thing is because infinity is not an exact number, we're not going to talk about plus or minus infinity being a maximum or minimum. Okay? So infinity is not an exact number, so that can never be our max or min. So do we have a minimum or do we have a maximum? A minimum, right? I have a smallest value right here. So I have a minimum at x equals 0, and the minimum is f of 0, which equals 0, right? So I'm talking about my y value there. Okay, so let's do number 4. So a relative minimum or relative maximum means I'm just putting a little interval around an area. It's not saying the absolute minimum or maximum. It's relative, so I'm talking about some small portion of x values. I can have a relative minimum or relative maximum. So do you guys see any minimums or maximums? So here again, I have a relative minimum because it's the smallest on this interval. That's what relative means. It's the smallest on this interval. Even though this goes down to negative infinity, if I cover up a portion of the graph and only look at a certain portion, then that means it is a minimum. So I have a minimum at x equals 0 of f of 0, which equals 0. And then for my maximum, if I cover up a portion, that's the largest. So I have a max at x equals 2 of f of 2, which looks like that equals 5. So those would be my answers to that. Do you guys have any questions?